All right, let's do this one. So they don't really give us any numbers, but we can kind of look at this. So we feel 50% heavier. That is the force normal. And true weight is force gravity. Through a dip of 30 radius, what's the car's speed? So let's start setting this up, and we always go back to a dip with radius of 30 meters. And at this point, we're going to say force gravity is down, force normal is up, and the acceleration is up as well, in this case at this dot. So the force normal is going to be positive, which is okay. I'm going to go to force normal minus force gravity equals mv squared over r. My force normal is heavier than my true weight. So this is really 1.5 times force gravity, because they said this is bigger than, or this one's bigger than force gravity, minus force gravity equals mv squared over r. Since they're both force gravity, I could say 1.5, whoops, sorry about that. What's 1.5 minus, there's a hidden 1, oh, gee whiz, I hit the wrong button. This is force gravity. There's a hidden 1 there, so 1.5 minus 1 is 0.5. Force gravity equals mv squared over r. So 0.5 mass times gravity, because that's what force of gravity is, equals mv squared over r. We need to solve this for v, so I need to get v all by itself. I'm going to times both sides, multiply both sides by r, and then divide by mass. Right? Whoops, wrong color. Mass over there, but I have to do mass there. It's also gone. And then I'll multiply both sides by radius. So v squared equals r times 0.5 gravity, which is 9.8 meters per second squared. And that's all I have, right? I have r 0.5 gravity, mass is gone, v squared, so let's square root both sides, and then we'll put some numbers in. The radius we decided was 30 meters times 0.5 times 9.8 meters per second squared. Give me some room here. And I'm going to the handy dandy calculator. And I get v, remember you got to square root your answer of this. V equals about 12.1 meters per second. So kind of different than what we've done, but if you kind of think your way through it, that one's not too bad. Bye-bye.